Hi everyone, in this video I am going to solve Cambridge International AS and A-Level Mathematics Paper 1 Pure Mathematics 1 in a session May-June 2022 Paper 1-2. So let's start with the first question. Question number 1, the coefficient of x4 in the expansion of 3 plus x to the power 5 is equals to the coefficient of x square in this expansion. Find the value of the positive constant a. A should be a positive constant, keep it in mind, right? Okay, so we have to expand this and find out the coefficient of x square and expand this and figure out the coefficient of x square for this and x4 for the other one. Let me expand it. 3 plus x whole power is 5. We have to expand and get the coefficient of x4. Okay, so the first term to the power 5 plus 5c1, the first term power is reduced by 1, it is 4, and the second term power is 1, plus 5c2, the first term power is 3 and the second term power is 2, plus 5c3, the first term power is 2 and the second term power is 3 increased by 1, 5c4, the first term power is now 1 and the second term power is 4. Now here you can see this is a constant term, x square, x cube and x4 term. We need to find the coefficient of x4. So now from here we can say x4 term is basically 5c4, 3 to the power 1 and x to the power 4. Okay, what is 5c4? 5c4 is 5 into 3 into x4. 5 times 3 is 15, x4. So the coefficient of x4 is 15, right? Now open the other expansion and figure out the x square term, coefficient of x square. So 2x plus a over x, this whole power is 6. Expand it and stop when you get the x square term, right? So the first term to the power 6 plus 6c1, this is x6 term. We need to find the coefficient of x square term. Okay, 6c1, the first term to the power 5 and the second term to the power of 1. Now this is 5 and 1, so 5 minus 1, 4. This is x4 term. Okay, this is 6c2, 2x to the power 4 and ax to the power 2. Now this is x square, this is x4. So 4 minus 2, this is x square term, right? So we can say x square term becomes, this is x6 term, this is x5 and x1. So 5 minus 1, x4 term. This is x4 and x square. 4 minus 2, this is x square term. 6c2, 2x to the power 4 and a over x to the power whole power is 2, right? What is 6c2? 6c2 is 15 and 2 to the power 4 is 16, x4, a square over x square, right? 15 times 16, 240, 240 a square and x to the power 4 and x to the power negative 2. So bases are same, we can add the power. So 240 a square x square, 4 minus 2, this is x square, coefficient of x square is this term, right? Now we can say the x4 coefficient, the coefficient of x4 in this expansion is equals to the coefficient of x square in this expansion. So these two coefficients are equal and we have to find out the value for a, but it should be positive, right? A should be positive. So what information we have given, that x4 coefficient is 15, that is equals to x square coefficient, which is 240 a square, right? Let me solve for a. So 15 divides 240, 15 divides 240, this is your a square, or we can say a square is 1 over 16. Now to get the value for a, take a square root on both sides And when we do the square root on both sides, the answer should be in plus and minus. So root of answer is 1 by 4. So here the a value is a is equals to plus minus 1 by 4. So it is given in the question that the value of a should be a positive constant, right? Since a should be positive, so a should be equals to 1 over 4. This is the solution for a. Question number 2. The second and third terms of geometric progression are 10 and 8 respectively. 10 is the second term and 8 is the third term, right? Okay, find sum to infinity. Okay. So when we have a geometric progression, the term formula, the nth term is equals to a r to the power n minus 1, right? So what we have given? We have given the second term t2, which is equals to a r to the power 2 minus 1, which is 1. So t2 is equals to 10. So 10 is a r, and the other thing t3 with third term we have given, which is a r, 3 minus 1 is 2. So 8 would be equals to a r square. Okay, with the help of these two equations, the first step is to figure out the a value and the r value. Okay, all right, this is your first equation and this is your second equation. Okay, we can say from equation 2 we can say a r into r would be equals to a. We can write down a r square into r times r, and now we know a r is equals to 10. Put equation 1 here, the value of a r, which is equals to 10. So 10 times r is 8, and r would be equals to 8 over 10, and that is 0.8. The r value is 0.8. Okay. Now when we get the r value, just substitute the r value into this equation to get the a value. Okay. Put r equals to 0.8 in equation 1. So a is 10 over r, right? From here a value is 10 over r. So we have 10 over 0.8. So a value is 8. No, 10 divided 0.8. 12.5. This is your a value, right? Now back to the question, what is sum to infinity? S infinity is a over 1 minus r, but when r is between minus 1 and plus 1. The sum to infinity only exists when the r common ratio is should be between minus 1 and plus 1. Now the value for the common ratio r is 0.8. So it is in the range less than 1. Now S infinity, the A value is 12.5 divided by 1 minus R is 0.8. Just simplify. So 1 minus 0.8 is 0.2. So S infinity is 12.5 divides 0.2. 12.5 divides 0.2 is 62.2. 62.5, sorry. This is the value for sum to infinity. Question number 3. The equation of a curve is such that its first derivative is given. It is given that the curve passes through the point 4 and 5 by 2. Find the equation of curve. Okay, this is pretty simple. So the derivative dy over dx is given to us, which is equals to 3 4x minus 7 to the power 1 by 2 minus 4x to the power minus 1 by 2. To find the equation of curve, we have to integrate both sides with respect to dx. Now this dx and dx is cancelled, derivative is cancelled out with integral. You are left with y is equals to 3 is a constant term. Here we do the power rule of integration. So this whole function 4x minus 7, the power is 1 by 2 plus 1. Whole divides 1 by 2 plus 1. Multiply 1 over the derivative of this function is 4x minus 7, derivative is just 4. Minus 4 is as it is, x power rule minus 1 by 2 plus 1 divides minus 1 by 2 plus 1 plus the constant of integration. Okay, now simplify this expression. So y is equals to 3 4x minus 7, 1 by 2 plus 1, 1 plus 2 is 3 by 2 over 3 by 2, multiply 1 by 4 minus 4, here x to the power minus 1 and plus 2 is 1 by 2 over 1 by 2 plus the constant of integration. So y would be equals to 3, multiply 3 by 2 becomes 2 by 3 and multiply 1 by 4, and this function is 4x minus 7 and its power is 3 by 2. Minus 4, 1 by 2 is 2 by 1, x to the power 1 by 2 plus the constant of integration. Okay, so 3 is cancelled with 3, 2 times 2 would be 4. So y is 1 by 2, 4x minus 7 to the power 3 by 2, minus 2 times 4 is 8, x to the power 1 by 2 plus c. Now we have to put this point because the curve passes through this point. So if the curve passed through this point, then it means that point lies on the curve. If the point lies on the curve, it must satisfy the curve 4 and 5 by 2. So when x value is 4 and the y value is 5 by 2. Okay, let me simplify. Y value is 5 by 2 is equals to 1 over 2. The x value is 4. 4 times 4 minus 7 and it's 3 by 2 minus 8. Now we have 4 to the power 1 by 2 plus the constant of integration. So this expression is 5 by 2. Simplify this expression. 4 times 4 is 16 and 16 take away 7, 9, and its power is 3 by 2, 27, multiply 1 by 2, 27 by 2. Okay, minus 8 and 4 to the power 1 by 2, this is negative 16 plus the constant of integration. Now this is 5 by 2 minus 27 over 2 and plus 16 is your c value. This becomes negative and this becomes positive and you shift to the left. Okay, 5 by 2 minus 27 by 2 and plus 16, 5. 5 is the value for c. So just plug the value of c. 5 over here, you will get the equation of curve. Equation of the curve becomes y equals half 4x minus 7 to the power 3 by 2 minus 8x to the power 1 by 2 plus 5. That is the equation of curve. Question number 4. The first, second, and third term of an arithmetic progression are k, 6k, and k plus 6 respectively. Part A, find the value of the constant k. Okay, we have given first, second, and third term of the arithmetic progression, right? Okay, so the first term is k. Okay, so term 1 is k, term 2 is 6k, and term 3 is k plus 6. Okay, so since it is an arithmetic progression, so for arithmetic progression we have a common difference d, and d should be equals to the second term minus the first term. That should be equals to the third term minus the second term. With the help of this equation we can easily get the value for k. Second term minus the first term, so 6k minus k equals to third term k plus 6 minus the second term which is 6k. Now 6k and minus k is 5k, and here we have 1, and minus 6 is minus 5k, and plus 6 is as it is, right? So 5k plus 5k equals to 6. I just shifted the 5 on the other side. It becomes 10k equals to 6, and the k value is 6 over 10. 2 times 3 is 6, 2 times 5 is 10, or the k answer is 3 by 5. This is a solution for k. Okay. Now for part B, find sum of the first 30 terms of the progression. This is arithmetic progression. The first term is given, which is k. The second term is 6k. The third term is k plus 6. Okay. All right. So now the k is 3 by 5. The k is 3 by 5. Now this is 6 into k 3 by 5. And this is 3 by 5 plus 6. Okay. The first term is 3 by 5. The second term is 6 times 3 by 5. 18 over 5. And the third term is 3 by 5 plus 6 is 33 over 5. For the sum, we need the first term and we need the common difference. Now, what is the d value? Now, the d is, as we have given that it is arithmetic progression, right? So it has a common difference. The difference between these two terms and these two terms must be same. So 18 over 5 minus 3 over 5. So 18 minus 3 divided by 5 is 3. 3 is a common difference. Okay. Now for Sn is n over 2 into 2a plus n minus 1 into d. So d is 3, n is 30, and a is 3 by 5. The first term is the a. So plug everything. So S30, n value is 30 divided by 2 into 2 times the a value is 3 over 5 plus n value is 30 minus 1 and the d value is 3. Okay. So S30 is 2 times 15 is 30. Okay. 2 times 3 by 5 is 6 over 5. 30 minus 1 is 29 times 3 is 87 plus 87. Okay, 87 add up with 6 over 5 is 1, and multiplying by 15 is 1323. So S30 is 1323. This is a sum of first 30 terms of that arithmetic progression. Question number 5. The equation of a curve is, and the equation of the line is, where k and a are constants. These k and a are constants. Part A. Given that the curve and the line intersect at a point with x coordinate 0 and 3 by 4, find the values of k and a. Okay, so the point of intersection, right, the x coordinate we have given. So they intersect, the curve and this line, they two intersect when the x value is 0 and the x value is 3 by 4. Okay, so the curve is 4x square minus kx plus 1 over 2 k square equals to x minus a. The curve and the line, they both are equal. You will get the point of intersection, and the x coordinate of those point of intersection are 0 and 3 by 4, right? So here we can say at x is equals to 0, they are equal. Solve for a and k. You will get the equation 4 into 0 square minus k into 0 plus 1 over 2 k square, x value 0 minus a. So this is 0, this is 0, these values. 1 by 2 k square equals to negative a. That is your first equation. Okay. The second is they are equal at x is equals to 3 by 4. Just substitute x value 3 by 4, right? Okay, so 4, 3 by 4 square minus k, 3 by 4 plus half k square equals to x is 3 by 4 negative a. Okay, now we can say 4 into 3 by 4 square 9 by 4 minus 3 by 4k plus 1 over 2k square equals to 3 by 4 minus a. As you know that from equation 1 we have the value of negative a. So here we can say put equation 1 here. Just plug the value of negative a, which is half k square. So here we have 9 over 4 minus 3 by 4 k plus 1 by 2 k square equals to 3 by 4. So negative a value is half k square. Okay, shift all the terms to the left now. 9 by 4 minus 3 by 4k plus 1 over 2k square minus 3 by 4 minus 1 over 2k square equals to 0. Now with positive and with negative both are cancelled out, right? Now here we have simplify 9 by 4 and 3 by 4. 9 by 4 subtract 3 by 4, this is 3 by 2. So 3 by 2, I simplified these two and just this is left minus 3 over 4k. We can solve for k equals to 0. So minus 3 over 4k equals to minus 3 by 2. Negative 3 and negative 3 is cancelled out. 1 over 4k equals to 1 by 2. So multiply both sides by 4. So k would be equals to 4 divided by 2 and 2 times 2 is 4. So from here we get the k value which is equals to 2. We got the k which is equals to 2. Now substitute this k value into your first equation and solve for a. Now put k values to 1 over 2 k is 2 square is equals to minus a. Okay. So this is 1 by 2, 2 square is 4, this is minus a. 2 times 1 is 2, 2 times 2 is 4. So 2 is equals to negative a. So what is a? So the a value is negative 2. A is negative 2 and k is positive 2. These are the values for a and k. Now for part B, given instead the a value is minus 7 by 2. Okay, find the values of k for which the line is tangent to the curve. Okay, so this line is tangent to the curve. Okay, now when a value is minus 7 by 4, the equation of the curve is, the curve equation is same. We have k in the curve equation, which is y equals to 4x square minus kx plus half k square. This is your curve. And the equation of line is when a value is minus 7 over 2, right? So the equation of line is y equals to x minus a. So y is equals to x minus, and the a is minus 7 by 2. So this is x plus 7 by 2. This is the equation of line. Okay. Now this equation of line is tangent to the curve. This line is tangent to this curve. We need to figure out the values of k. If it is tangent to the curve, it touched the curve at one point, right? We know that when line is tangent to the curve, it intersect at one point. Okay. And when it intersects at one point, the discriminant should be b square minus 4ac should be equals to 0 for one point of intersection, right? Now let me figure out their point of intersection. So the y value is 4x square minus kx plus half k square equals to x plus 7 by 2, right? Okay, now put them equal to get the point of intersection. Shift everything to the left. So 4x square minus kx minus x. I shift x on the other side, plus half k square and minus 7 by 2 equals to 0. Now the x square coefficient is just 4. The x coefficient is minus k and minus 1 is the coefficient of x, and the constant term is half k square minus 7 by 2. This is a constant term. Okay. Now, as we know that the line is tangent to the curve, so they have one point of intersection, their discriminant should be equals to 0. So b square minus 4ac should be equals to 0, and we need to figure out the values of k. So what is a? A is a coefficient of x square, b is a coefficient of x, c is the constant term half k square minus 7 by 2. Now b is minus k minus 1 whole square minus 4. The a is 4 and c is k square divided by 2 minus 7 by 2. This should be equals to 0, right? Now take negative sign common. Negative 1 square or k plus 1 whole square minus 4 times 4 is 16. This is k square divided by 2 minus 7 by 2 equals to 0. So in this step I did 4 times 4 and I took a minus sign common. So minus 1 square and k plus 1 is left. K is positive and 1 is also positive. Minus 1 square is 1. K square plus 2k plus 1. I opened a plus b whole square. A square plus 2ab plus b square. Minus 16 is multiplying with k square over 2. And minus 16 is multiplying with minus 7 by 2 equals to 0. Now here we have k square plus 2k plus 1. 2 times 8 is 16, so minus 8k square. Negative and negative is positive. 2 times 8 is 16 and 8 times 7 is 56 equals to 0. Now this and this are the coefficient of k square, so minus 7 k square. K is just 2k and the constant term is 57 equals to 0. Now this is a quadratic equation in K, so it is better to factorize, apply the quadratic formula. I don't think factorization is easy. Yeah, apply the quadratic formula over here. So the quadratic formula says K is equals to negative b plus minus square root b square minus 4ac divides 2a. Now what is a, b and c? A is a coefficient of k square, b is a coefficient of k, and c is a constant term. So plug everything into the formula. Now k is equals to negative of b plus minus square root b square minus 4ac divides 2 times of a, which is negative 7. K is equals to minus 2 plus minus square root, okay, minus 4 into minus 7 into 57 and plus 2 square 1600 1600. 2 times 7 is 14, so negative of 14 with negative sign, right? So k is, what is root of 1600? 40 is the root. Minus 2 plus minus 40 divided by negative 14. Okay. Now here we have two values of k. K is equals to minus 2 plus 40 over negative 14, or k equals to negative 2 negative 40 over negative 14. So the first value of k is minus 2 plus 40 divided by negative 14 is minus 19 over 7. And the second one is minus 2 minus 40 divides negative 14 is 3. The k value is 3. So these are the two values of k. Negative 19 over 7 and 3. Question number 6. The diagram shows the curve with equation and the line with equation. We have a line and we have the curve. Okay. Find the exact area, means in terms of fraction, not in terms of decimal, of the shaded region. The shaded region is bounded by the curve and the line. Since the curve is at the top, we can integrate the curve, subtract the integration of the line. But between these 2 points of intersection, we have to integrate, which is bounded by the line and the curve. So first thing is to find out the point of intersection of the curve and the line. Okay, so the point of intersection of the curve and the line. Okay, put the curve and the line equal. So we can say 5x to the power 1 by 2 equals to 2x plus 2. Okay, or we can say 5x to the power 1 by 2 minus 2x minus 2 would be equals to 0. Okay, here we can suppose that 1 by 2 is your t. Sorry, x to the power 1 by 2 is your t value, right? So let us suppose that t is x to the power 1 by 2 and t square is x. We can say x to the power 1 by 2 is t, and when you square on both sides, this is t square and this is x1 power 1 by 2 whole square. We are just left with x, right? Put it back. So 5t minus 2t square minus 2 equals to 0, or minus 2t square plus 5t minus 2 equals to 0. Take negative sign common. 2t square minus 5t plus 2 equals to 0. Now shift the negative sign on the other side. 2t square minus 5t plus 2 equals to 0. Okay. Now this is a quadratic equation and a variable t. Let me factorize it. 2 times 2 is equals to 4. 4 times 1 is equals to 4. And when you do minus 4 and minus 1 gives you negative 5. So break the meta negative 5. 2t square minus 4t minus t plus 2 equals to 0. Let me take 2 and t common. T is left, minus t is already common. 2 times 2 is 4. Minus 1 is common. T minus 2 is left. T minus 2 is a factor and 2t minus 1 is the factor. Okay. So from here the t is minus 2 equals to 0, or we can say 2t minus 1 equals to 0. So t is 2 and here 2t is equals to 1 and t value is 1 by 2. Now put it back. What is your t? T is x to the power 1 by 2, right? So here root x is 2 and here root x is 1 by 2. Okay. In order to get the value of x, take a square on both sides. So here x is 2 square is 4 and here x is 1 square is 1, 2 square is 4. 4 and 1 by 4. 1 by 4 is 0.25. Yeah, 0.25 is 1 by 4. So 0.25 and 4, these are the 2 points of intersection. So this point of intersection we can say is 1 by 4. This point, the lower limit is 1 by 4 and the other point is, this is positive 4. So we have to integrate the curve from 1 by 4 to 4, subtract the integration of the line from 1 by 4 to 4. That would be the area of the shaded region. Okay. So here we can say the area becomes integration from 1 by 4 to 4 of the curve. Curve is at the top, yes. The curve is 5x to the power 1 by 2 dx minus integration from 1 by 4 to 4. The line is at the bottom, which is 2x plus 2. 2x plus 2 with respect to dx. Okay. Let me integrate it. 5x to the power 1 by 2 plus 1 over 1 by 2 plus 1, the power rule of integration. The limits are from 1 by 4 till 4 minus 2x integration is x squared divided by 2 minus 2x, and the limits are from 1 by 4 to 4. Okay. Further simplification, we have 5x to the power 3 by 2 divides 3 by 2. The limits are from 1 by 4 till 4, minus this is x square minus 2x, and the limits are from 1 by 4 till 4, because this 2 and this 2 is cancelled out, right? Simplified further, 5 multiply 3 by 2 is 2 by 3, and x to the power 3 by 2, and the limits are from 1 by 4 till 4, minus x square minus 2x from 1 by 4 till 4. Okay. 5 times 2 is 10 over 3, x to the power 3 by 2. You have to put the limits from 1 by 4 to 4, and minus x square minus 2x, and the limits are from 1 by 4 to 4. Now we have to apply the limits. Applying the limits, the upper limit subtract the lower limit. Okay, so when we apply the limits, the area becomes, the upper limit is 4, the lower limit is 1 by 4, right? 10 by 3, the upper limit is 4 to the power 3 by 2, minus the 10 by 3, the lower limit is 1 by 4 to the power of 3 by 2. So we have done with the first one, minus the upper limit is 4. So we have 4 square minus 2 into 4. Subtract the lower limit is 1 by 4. So 1 over 4 square minus 2 into 1 by 4. Okay. Okay, now simplify. Okay. 10 by 3 okay, 10 over 3 multiply by 4 to the power 3 by 4. Wait, we need 3 by 2. 4 to the power 3 by 2 times it by 10 divided by 3. 80 over 3. Okay, 1 by 4 to the power 3 by 2 times 10 over 3, 5 over 12. Okay, 4 square is 16, minus 2 into 4 is 8. So this answer is 8. Minus, simplify this one. 1 over 4 is square, and minus 2 into 1 by 4. Minus 7 over 16. Minus minus becomes plus 7 over 16. Okay. So we need to figure out the exact area, right? So 80 over 3 and subtract 5 over 12. This becomes 104, 105 over 4. 105 divided by 4. Subtract 8 plus 7 over 16. 135 over 16. Okay. 105 divided by 4. Subtract 135 over 16. 2. Wait a second, I did the mistake over here. It's 2x plus 2. So these are positive. This is plus. So when you do, it's negative of something, right? It's upper limit. Okay, this is the first. Sorry. This is for the lower limit. It's plus. And it's plus, and this minus is for this is upper limit, subtract the lower limit, right? So simplify this. 4 square is 16, and 16 plus 2 times 4 is 8. So this is 24, right? So this is 24. Subtract the lower limit is 1 over 16. and plus 2 times 1 is 2, 2 times 2 is 4. 1 over 16, sorry, 1 over 16 plus 1 by 2, 9 over 16. With this is the negative sign for the formula for the limits, right? So 24 minus 9 over 16 is 375 over 16. 375 over 16. Okay, so 105 divided by 4, subtract 375 over 16. 45 over 16 is the exact area. So this is the solution. This is the answer for the exact area, which is 45 over 16. Question number 7. The diagram shows a sector OBAC. OBAC of a circle with the center O. If O is the center and radius is 10, then OC is 10, OA is 10, OB is 10. Everything is 10. O to C is also 10 centimeter. O to A is also 10 centimeter. Okay. The point P lies on OC. Point P lies on OC and BP. This line is perpendicular to OC. All right. Angle AOC. AO and C. This is pi by 6, and the length of the arc AB is 2. So arc length AB. This arc length is also 2. It is given. Part A, find the angle BOC. B, O, and C. This whole angle we need to figure out. Okay. So this is basically this angle plus this angle. You will get this whole angle BOC, right? So the information we have given that it is in radians, right? So the arc length is radius times theta. Since the arc length is 2 centimeter, the radius is 10 and 10, and we know on the theta. This is your theta, right? So 2 over 10, this is your theta. Theta is 2 times 1 is 2, 2 times 5 is 10. So this theta is 1 by 5, and this is pi by 6, right? This implies angle BOC is the sum of 1 over 5 and pi by 6 in radians, right? 1 by 5 plus bracket pi by 6 is 0.724 up to 3 decimal place radians. This is the angle. Now for part B, hence find the area of the shaded region BPC, giving your answer correct to 3 significant figures. BPC. This is a shaded region. B, P, and C. Right. So area of this shaded region is basically figure out the area of this sector and subtract the area of this triangle. You will get the shaded area, right? So the shaded area is area of a sector O, the whole sector OBAC, subtract area of a triangle uh, BPO, right? So from the whole sector, as you can, we have given that it is a sector. So area of a sector B, O, B, A, C, subtract area of this triangle B, P, and O, right? Area of a sector is half radius square theta. right? Its formula. So we have the radius of the sector and we have the theta for this sector, right? Area of a triangle is its base and height, right? Okay. So for this triangle, area of a triangle is half base and the height. We don't know the base, we don't know the height, but we have this side, this angle we have given. We can easily find out the base and the height, right? Okay, so if I can draw this triangle separately over here and figure out. Okay, all right. So this is B, this is P, and this is O, right? VPO. This is P is a right angle. This is 10 centimeter, and this whole angle BO, and that angle would be 0.724 radians. Okay, so for this angle, opposite over hypotenuse is sine, adjacent over hypotenuse is cos. By using this ratio, we can easily find out the values, right? For right angle triangle, we can say sine of 0.724 would be equals to opposite BP, and the hypotenuse is 10. So we can get the value for BP, opposite over the hypotenuse, right? It should be in degrees, right? Radians, right? Okay. Convert my calculator, sorry, into radian mode, right? Sine 0.724 and multiply by 10. This is your BP, right? Sine 0.724 multiplying by 10 is BP. So the BP is 6.623 or 6.62. 6.62 centimeter is the length of B and P. 6.62. Same we have to do for cos. So here we can say cos 0.724 is adjacent is OP over the hypotenuse is 10. Solve for OP. So 10 times cos of 0.724 is OP. Cos 0.724 multiplying by 10 is 7.49 or 7.5. 7.49 centimeter is OP. 7.49. Okay, we have OP now. We can easily find out the shaded area. Now the shaded area is area of a sector OBAC. The sector OBAC. Area of a sector is half radius square, and this is the theta. So area of a sector is half radius square theta minus area of a triangle is half base times height. So half the radius is 10, take it square, and theta is 0.7 multiply 24 minus half for the triangle, the base and the height. So this is the base and this would be the height, right? So base of the triangle is 7.49 and the height of the triangle is 6.62. Simplify. 1 by 2 multiply 10 square multiply 0.724, 36.2. Okay, 1 by 2 times 7.49 times 6.62 with negative 24.7919. 36.2 subtract answer 11.4081. This is 11.4081. We need to figure out the area up to three significant figures. So the three significant figures, the area is 11.4 centimeter square. That is the area. Up to three significant figures. All right. Question number 8. The equation of a circle is given to us. The points A 1 1 and B 2 negative 6 lies on the circle. If the point lies on the circle, it must satisfy the circle, right? Part A, find the values of A and B and hence find the coordinates of the center of the circle. Just the center of the circle, not the radius, okay? All right, so these 2 points lies on the circle. So the point A is 1 1. It must satisfy the equation of the circle. So when x is 1, so we have 1 square, y is also 1, 1 square plus a into 1 plus b into 1 minus 12 equals to 0. 1 plus 1 plus a plus b minus 12 equals to 0. 2 plus a plus b minus 12 equals to 0. A plus b minus 10 equals to 0. Or we can say a plus b equals to 10. This is your first equation. Okay, the second point B also lies on the circle, which is 2 and negative 6. X is 2 and the y is negative 6 now, right? So the x square plus y square plus ax plus by minus 12 equals to 0. 2 square, 2 times 2 is 4, 6 times 6 is 36 plus 2a minus 6b minus 12 equals to 0. So 2a minus 6b, and what is 4 plus 36 and minus 12? 4 plus 36 and minus 12 is 28. So positive 28 equals to 0. Alright, so now here we have 2a minus 6b equals to negative 28. Now we can take a common on both sides. A minus 3b, and also here we can take 2 common. 2 times 1 is 2, 2 times 4 is 8. Okay, so this 2 and this 2 is cancelled out. A minus 3b is equals to negative 14. That is my second equation. With the help of these two equations, we can easily get the values of a and b, right? So we have, if I can just subtract the two equations, right? So we can say subtract equation 1 and equation 2. So the equation 1 is a plus b is equals to 10. Equation 2 is a minus 3b is equals to negative 14. When you do subtraction, so you have to change the signs, negative, and positive, right? So plus a and minus a is cancelled out. Plus b plus 3b is 4b. Plus 10 plus 14 is 24, right? So b would be equals to 24 divided by 4, and 4 times 6 is 24. So b is 6. We have done with the b value, which is equals to 6. Now we got the b value. Plug the b value into your first equation or your second equation and solve for a. So here we can say put b equals to 6 in equation 1. Okay, so the equation 1 says a plus b would be 10. So a would be equals to 10, take away 6, a is 4. So we have done with a and b. So a is 4, b is 6. Okay, now the next thing is to figure out the coordinates of the center. Now the equation of circle is, by plugging the values of a and b, a is 4 and b is 6. X square plus y square, a value is 4, 4x, and the b value 6 plus 6y minus 12 equals to 0. So convert it into standard form. So x square plus 4x plus y square plus 6y and negative 12 equals to 0. Complete the square. We have x square plus 2 into x into 2, a square plus 2ab, right? So 2 times 2 gives you 4. So we have to add 2 square and subtract 2 square. Now with y, we have y square plus 2 into y plus what makes 6? 3. So plus 3 square and minus 3 square. Negative 12 equals to 0. Combine the first three terms. This is x plus 2 whole square and minus 4. Combine the first three terms. This is y plus 3 whole square and negative 9, negative 12 equals to 0. 9, 12, and 4. Okay, minus 4, minus 9, minus 12 is negative 25. Okay, so x plus 2 whole square plus y plus 3 whole square equals to 25. Shift the negative on the other side, so it becomes positive, right? So this becomes x minus minus 2 whole square plus y minus minus 3 whole square equals to 5 square. Now this is exactly into the form x minus a whole square plus y minus b whole square equals to the radius square. Now the radius is 5 and the a and b are the coordinates of center, which is negative 2 and negative 3. So here we can say the coordinates of center are minus 2 and minus 3. These are the coordinates of center of a circle, and the radius is 5. So they do not ask for the radius. That is why I'm not mentioning. Now for part B, find the equation of tangent to the circle at point A, giving your answer in the form of px plus qy equals to k, where p, q, and k are integers. Right. Equation of tangent to the circle at A. So keep it in mind, for equation of tangent, we need the point. So we have the point A whose coordinates are 1, 1. And we need the gradient of tangent at point A. A coordinates are 1, 1. So we need the gradient as well. Okay. So from equation of circle, we can easily figure out the gradient. So equation of circle is we have the equation of circle. Let me write it down. X square plus y square plus 4x plus 6y and minus 12. This would be the equation of circle after getting the values of a and b. I just write down this. Okay. Now we need to figure out what is the gradient at 1, 1, the point A. So for differentiate with respect to x. Okay. D by dx, the derivative of first term is 2x d over dx of x. 2y d over dx of y plus 4d over dx of x plus 6d over dx of y minus 12. Derivative is just 0. Derivative of the constant term is 0, right? So here we have left with 2x dx over dx is 1 plus 2y dy over dx plus 4 dx over dx is 1 plus 6 dy over dx is equals to 0. Now what are the coefficients of dy over dx? 2y and plus 6. And the other terms are 2x plus 4 equals to 0, right? Okay. Now 2y plus 6 is a coefficient of dy over dx equals to minus 4 and minus 2x, and dy over dx becomes minus 4 minus 2x divides 2y plus 6. Okay. Now, what is the derivative at the point A, which is 1 and 1, when x is 1 and the y is also 1, right? Okay, so dy over dx at 1, 1 minus 4 minus 2 into 1, 2 into 1 plus 6. Okay, so this becomes, we can say minus 4 minus 2 over 2 plus 6. Minus 4 minus 2 is minus 6. 2 plus 6 is 8. So minus 6 divided by, sorry, minus 6 over 8, 3 by 4, with negative 3 by 4 is the gradient. Right. Now we can write down the equation of tangent. Equation of tangent at the point A, which is 1, 1. We can write this down as y e minus y naught is equals to m into x minus x naught. Okay. So y minus y naught is 1, m is negative 3 over 4, and x minus x naught is 1. Okay, cross multiplied. 4 is multiplying with y minus 1, and negative 3 is multiplying with x minus 1. 4y minus 4 is equals to minus 3x plus 3. Okay, so 4y plus 3x, and this would be equals to 3, and shift the 4 on the other side becomes positive 4. 3x plus 4y is equals to 7, and this is in the form of px plus qy equals to k, where p, q, and k are integers, right? Px plus qy equals to k. P, q, and k are integers, 3, 4, and 7. These are integers. Okay. Question number 9, the equation of the curve is, this is the equation of curve for x is greater than minus 1 over 3. Part A, find the first derivative and second derivative. Okay, let me start with the first derivative, dy over dx. 3, x derivative is 1. 1 is a constant term, its derivative is 0. Minus 4 is outside, applying the power rule of differentiation. First, write down the power, the base function 3x plus 1, and then we do the power minus 1, and the derivative of the base function is just 3. Okay, so we are left with 3 minus 4 times 3 is 12 divided by 2, and 3x plus 1, and here we have 2, and 1 minus 2 is minus 1 by 2. Okay, so the first derivative is dy over dx, 3 minus 6, 3x plus 1 to the power negative 1 by 2, because 2 times 6 is 12. This is your first derivative. Now we need to figure out the second derivative. D2y over dx square is 3 is a constant term, its derivative is 0, minus 6. Now applying the power rule, minus 1 by 2, power base function, now power minus 1, and the derivative of the base function is just 3, right? So the second derivative is negative times negative is positive, and 6 times 3 is 18. 18 divided by 2, and 3x plus 1, and we have minus 2. Minus 1 minus 2 is minus 3 divided by 2. This implies we have the second derivative d2y over dx square. 2 times 9 is 18. 3x plus 1 to the power negative 3 by 2. This is your second derivative. Now for part B, find the coordinates of the stationary points of the curve and determine its nature. Okay, so coordinates, x and y, both coordinates we need to figure out. So as we know that for stationary points, we need to put the first derivative dy over dx equals to 0. right? So we have done the first derivative in part A. So we need to put this first derivative equals to 0. So which is 3 minus 6 over square root of 3x plus 1. This should be equals to 0. Negative 6 divides root 3x plus 1. This should be equals to negative 3. Negative is cancelled with negative. 3 times 1 is 3. 3 times 2 is 6, right? So 2 over root 3x plus 1 would be equals to 1. Now cross multiply. So 2 would be equals to root of 3x plus 1. In order to get this root, we have to take a square on both sides. Okay, this is 4 and this is 3x plus 1. So 4 take away 1, this becomes 3x. 4 take away 1 is 3, would be equals to 3x. So from here the x coordinate is 1. So when the x coordinate is done, we need to figure out the y coordinate by plugging the x value onto the equation of curve. This is the equation of curve I'm plugging over here. So here we can say put x is equals to 1 in equation of curve to get the y coordinate. So the y coordinate is 3x plus 1 minus 4 into 3x plus 1 to the power 1 by 2. Okay, so now the y coordinate is 3 plus 1 minus 4, and this is 4 to the power 1 by 2. Y would be equals to 4 minus 4, and here 3 plus 1 is 4, and this is 4 to the power 1 by 2 is 2. So y coordinate is 4 and minus 8. So the y coordinate is negative 4. Okay, so this implies the coordinates of stationary point are 1 and negative 4. These are the coordinates of the stationary point. Okay, now the next step is to determine the nature of the stationary point, whether they are maximum or minimum, right? So we know that for nature of stationary point, 1 and negative 4, we have to substitute the stationary point into the second derivative. And we have already done the second derivative. This is your second derivative, right? So what is your second derivative? D2y over dx square at x is equals to 1. 9 into 3 plus 1 to the power negative 3 by 2. This is your second derivative. 3 plus 1 is 4. 9 into 4 to the power negative 3 by 2. This is 9 over 8. So it is positive, right? When it is positive, so the stationary points are minimum. We can say stationary point is minimum because the second derivative is positive. It has a minimum nature. Question number 10. Functions f and g are defined as follow. We have f of x for x is not equals to 1 by 2 and g of x for x belongs to all real numbers. Part A. The diagram shows part of the graph of y equals to f of x. So this is a graph for f of x, right? This function f of x. Okay. State the domain of f inverse of x. Okay. So we have given the domain of f inverse is basically equals to the range of f of x. Keep it in mind that the domain of f of x, f inverse of x, this is the range of f of x. Okay, so in order to get the domain for f inverse, we need to figure out what is the range for f inverse. Okay, f function f of x, sorry. Now we have given the graph for the function f of x, so what is the range for this function? Okay, so range are basically the y values. So look at these y values. As you guys can see, this is the line y equals to 1. right? Y is equals to 1. Now we have y2, 3, 4, and here y is 0, -1, -2, -3, and so on. Now, what are the range, the outputs? You can see this curve shows that all the y values are more than 1, not exactly equals to 1. And this curve shows that all the y values are less than 1, not equals to 1. So the domain for f inverse, domain of f inverse of x is not equals to 1, or we can say we have you can say when y values sorry, the x values are x are greater than 1 and x values are less than 1, right? So basically the range of the function f of x is, what is the range for this function f of x? So this curve shows that all the y values are more than 1, and this curve shows that all the y values are less than 1, right, and not equals to 1. Okay, so range of f is y is not equals to 1, or we can say the y values are greater than 1 and the y values are less than 1. That is the range. So when we are dealing with the domain, so domain is basically the x, not the y variable, right? So range deals with the y variables and the domain deals with the x variables. So as we know that the domain of f inverse is a range of f, and the range of f is y is not equals to 1, or the y values are more than 1 or less than 1. So when we write down the domain for f inverse, we can say x is not equals to 1 or x is less than 1 or greater than 1, right? Okay, now for part b, find an expression for f inverse of x. Okay, we have the function f of x, so for this we have to put y equals to the function f of x. Y equals to f of x is 2x plus 1 over 2x minus 1. Then you have to switch the variables. X would be equals to 2y plus 1 over 2y minus 1, right? Now in the next step we have to solve for y. So cross multiplied, x is multiplying with 2y minus 1 equals to 2y plus 1. 2xy minus x would be equals to 2y plus 1. Now you have to combine the y terms, 2xy and minus 2y. These are the y terms, and the x terms are 1, and shift the x on the other side plus x, not the x term, x and the constant term. Okay, now take y common. We are left with 2x minus 2 equals to 1 plus x, and this y is 1 plus x over 2x minus 2, and this is my f inverse of x. That is the expression for f inverse of x, we can say. And this would be the domain for f inverse. Now for part C, find g f inverse of 3. So first step, we need to figure out what is f inverse of 3. F inverse of 3, this would be f inverse of x, right? 1 plus 3 over 2 into 3 minus 2. 1 plus 3 is 4. 2 times 3 is 6. Take away 2. So 4 divided by 4, that is equals to 1. So g inverse of 3 is 1. F inverse of 3 is 1. So g f inverse of 3, this is g f inverse of 3 is 1. So what is g of 1? So we have g of x is x square plus 4. So just substitute x value is 1. So 1 square plus 4, 1 square is 1, which is equals to 5. So here we can say g f inverse of 3, its value is just 5. That is the expression. Now for part D, explain why g inverse cannot be found. Okay, so g of x is this function, which is, we can say g of x is x square plus 4. Okay, so this is a parabola, and the domain we have given that x belongs to all real numbers, right? So it's a quadratic expression, and the graph of the quadratic equation is a parabola. So if I can draw the parabola, we can see this is how the parabola look like. Okay. As you can see, if you put x square plus 4 equals to 0, you will get x square equals to negative 4, right? And the x would be equals to square root of minus 4, and negative means no x-intercepts, right? So, but this is how the graph look like, right? So when x value is 0, the y-intercept is 4 over here. Okay, so and x belongs to all real numbers. X can be 0, positive numbers, and negative numbers, right? So for this, if you draw the vertical line test on g of x horizontal line, the horizontal line intersect the graph at 2 points, right? So that is why g inverse does not exist. We can say g inverse of x does not exist because g of x does not satisfy horizontal line test. When the graph of a function satisfies the horizontal line test, then inverse of that function exists. If it does not satisfy the horizontal line test, then the inverse does not exist. Horizontal line test, this is the first reason, or we can say g of x is not one-to-one function. G of x is not one-to-one function. One-to-one function is a function when you have for every input you have a unique output. You can see. So when you give some inputs, like if you put input 1, right, and minus 1, you have the same outputs. The y values are same, right? So the function is not one to one. This is one reason you can give that. That is why the inverse of that function does not exist. The second reason is the graph of the function does not satisfy the horizontal line test. That is why the inverse of that function does not exist. Okay, now for part E, show that this expression can be expressed as this form, and hence find the area of the triangle enclosed by the tangent to the curve y equals to f of x at a point where x is 1 and the x and y axis. Okay, so first we need to express this expression that 1 plus 2 over 2x minus 1. We have to express this into this form. Okay, so 2x minus 1 plus 2 divides 2x minus 1. I cross multiplied. This is 2x plus 1 over 2x minus 1. So it is proved. Okay, now we need to find the area of the triangle which is formed by the tangent to the curve at point x is equals to 1. So this is the same curve, you guys can see. This is the same curve, 2x plus 1, 2x minus 1. This is for the function f of x. So when view x is equals to 1, this is a point x is equals to 1. So here x is equals to 1. If I can draw the tangent at x is equals to 1, the tangent touch the curve at one point. We know that. So this is the tangent at x is equals to 1, right? So at x is equals to 1, I drew the tangent line which touched the curve at one point. So we have to find out the area of the triangle which is formed by the tangent line at x is equals to 1, the x-axis and the y-axis. So we need to figure out that the tangent line intersect the axis at what point, basically. Right, at this is the y-axis and this is a point of intersection for the x-axis, right? Okay, so first thing we need to figure out the equation of tangent, and then we have to find out the point of intersection. The tangent intersect at x-axis, y component is 0. The tangent intersect the y-axis, x component is 0. So the point is where they intersect the x-axis. You guys can see the point when x value is 1, the y value is 3 from the graph. You can easily guess that when x is 1, the y value is 3. And now we need to find out, for equation of tangent we need a point and we need the gradient as well. So find out the gradient, the derivative f prime of x at x is equals to 1. Okay, right. Now we have the function f of x, which is, you can write down this one or this one, both are okay. 1 plus 2 into 2x minus 1 to the power negative 1. So if I can find out its derivative, f prime of x, one derivative is 0, 2 is a constant number. Applying the power rule, power base function, we have power minus 1 and the derivative of base function is just 2. So 2 times 2 is 4, so we have minus 4 and 2x minus 1 to the power negative 2, or we can say minus 4 divides 2x minus 1 to the whole square, and you shift to the denominator, right? Now what is f prime of x at x is equals to 1? F prime of 1, right? Minus 4 divides 2 minus 1 whole square. So negative 4 to minus 1 is 1 square. 1 square is 1, so it is just negative 4, right? Now we need to figure out the equation of tangent. Equation of tangent at the point when x is 1, the y value is 3. The function, you can easily see on the curve, the y value is 3. When x is 1, the y is 3. Or if you're not understood, then just substitute x equals to 1 over here. So 2 times 1 is 2, 2 plus 1 is 3, 2 times 1 is 2, and 2 minus 1 is 1. 3 over 1 is just 3. Okay. Now for the equation of tangent, we have y minus y naught is equals to m into x minus x naught. All right. So equation of tangent, we need the point x naught, y naught, and we need m, the gradient, right? Y minus y naught is 3, m value is negative 4, and x minus x naught is 1. Okay, so this is y minus 3 is equals to minus 4x and plus 4. Y would be equals to minus 4x plus 4 and plus 3. Shift the 3 on the other side, becomes positive, right? Minus 4x and 4 plus 3 is 7. This is the equation of tangent. So this straight line equation of tangent is minus 4x plus 7, right? Plus 7, this is tell us that the y-intercept is 7. Okay, now let me for this equation find out the x and the y-intercept. So for x-intercept, put y would be equals to 0. When you substitute y value equals to 0, here we have 4x minus 4x plus 7 equals to 0. Now 4x minus 4x equals to minus 7, and x would be equals to 7 over 4. Negative sign is cancelled out. What is 7 by 4? 1.75 is the x-intercept. Okay, same, we need to figure out the y-intercept. For y-intercept, just put the variable x is equals to 0. When the x value is 0, the y equals to 7. Y equals to negative 4 into 0 plus 7. So here the y-intercept is 7. Now on the graph, you can see this y-intercept is 7 and this x-intercept is 7 over 4, or 1.75. So 1.75 is between 1 and 2, right? Okay, now we need to figure out the area of this triangle. The area of the triangle, which is enclosed by the tangent to the curve at x is equals to 1, the y-axis and the x-axis. So it is a right angle triangle, you guys can see. So if I can draw this triangle separately on this page. Okay. This is the tangent line, right? It is a right angle triangle. Now you guys can see, now from 0 to 7, this y length is 7, right? And from x length 0 to 7 by 4, this length is 7 by 4. We need to figure out the area of this right angle triangle, which is half base times height. So here, area of a triangle, area of triangle is half base times height. Okay, now we have half, the base is 7 by 4 and the height is just 7. 7 times 7 is 49. 2 times 4 is 8. 49 over 8. So this is the area of the triangle. 49 divided by 8. Question number 11. The function f is defined by, we have the function f of x for x is between 0 to 2 pi, where k is a constant. Part A, given that k is 3, find the exact solutions of the equation f of x equals to 0, right? So when k equals to 3, what is your f of x? So we can say when k equals to 3, my f of x becomes, f of x is 4 cos 4x plus cos square x minus k value is 3. This is my f of x. Now we have given that f of x is equals to 0. Just put f of x is equals to 0 and simplify the solutions, right? So 4 cos 4x plus cos square x negative 3 equals to 0. Okay, now this is a quadratic equation in cos square x, right? So we need to factorize it. 4 times minus 3 is minus 12. Find out the factors of negative 12 whose sum and difference should be equals to 1. Okay, if you can do 4 minus 3, this is just 1. Yes. 4 cos 4x plus 4 cos square x minus 3 cos square x and negative 3 would be equals to 0. Now taking 4 common and cos square of x common, we are left with cos square x and plus 1. Negative 3 is common, we are left with cos square x and plus 1 equals to 0, right? Now the factors are cos square x plus 1 and the other factor is 4 cos square x minus 3. This is equals to 0, right? Okay, now we need to put both factors separately. Equals to 0, cos square x plus 1 equals to 0, and the other one is 4 cos square x minus 3 equals to 0. Now here cos square x would be equals to negative 1, and here 4 cos square x is equals to 3, and cos square x would be equals to 3 by 4, right? In order to get rid of this square, so we need to take a square root on both sides. The square root of this with a plus minus, the square root of this side, and the square root of this side with a plus and minus. When we do the square root on both sides, the answer should be in plus and minus. Keep it in mind, right? Okay, now this square and the square root is cancelled out. Here we are left with cos x is equals to plus minus root negative 1. And whenever we have a negative sign under the square root, we have no solution. So we have no solution from here. It does not exist. You guys can see root negative 1, no solution. So we have only solutions from here. So the first cos x from here is plus minus square root of 3 divided by 2, because root 4 is 2, right? Now let me take these two cases, right? So the case 1 is cos x is root 3 by 2, and the other one is cos x is negative root 3 by 2. So first thing, we need to check that cos is positive and here cos is negative in which quadrant, and the domain we have given is from 0 to 2 pi, the whole circle, right? All the 4 quadrants. Okay, so before doing this, let me find out the base angle for both. The base angle and the base angle. So base angle we need to find without the signs, right? The positive or the negative. So cos inverse of root 3 over 2, and here again x is cos inverse of root 3 over 2. Whenever you have to figure out the base angle, you're not considering the negative signs, right? So it is in radians, right? So my calculator is in radians. Okay, that's good. Cos inverse root 3 divided by 2. This is pi by 6. Okay, so the base angle is pi over 6, and again here the base angle is pi by 6, right? Now we need to check that cos is positive and negative in which quadrant. Let me draw the coordinate diagram and see cos is positive and negative in which quadrant. This is a coordinate diagram, all right? Now, in the first quadrant, all trigonometric ratios are positive. Here, sine is positive. Here, tangent is positive. And here, cos is positive. And what are the operations? The first quadrant, we can say the base angle. The second quadrant, pi minus the base angle. Third quadrant, pi plus the base angle. And 2 pi minus the base angle. Now, you can see cos is positive in first and fourth quadrant. Here, cos equation, it says it's positive, right? You guys can see cos is positive in first quadrant and fourth quadrant, and here cos is negative in second and third quadrant. Okay, now we can write this down that cos is positive in first quadrant and in fourth quadrant. Okay, now what is the value of the angle? Angle is basically x. The x is in the first quadrant, the x is the base angle. The base angle is pi by 6. The second x would be equals to 2 pi minus the base angle. So 2 pi minus this base angle. Okay. So we can say 2 pi minus pi by 6. 11 pi by 6. This is 11 pi over 6, right? Okay, now for the second equation, we can say cos is negative in second and third quadrant, right? Now cos is negative in second quadrant and in the third quadrant. Okay. Now for the second quadrant, the angle would be equals to pi minus the base angle, and here pi plus the base angle. Okay. So what is pi minus the base angle? We can say pi minus pi by 6 would be 5 pi by 6, and pi plus pi by 6 is 7 pi by 6. Okay, so these are the four solutions: pi by 6, 5 pi by 6, 7 pi by 6, and 11 pi by 6. So the solutions, we can write this down. X would be equals to pi by 6, and then the next one is 5 pi by 6, 7 pi by 6 in arranged form. You can also write down as it is, that is okay. So these are the four required solution which belongs to 0 to 2 pi. Okay. Now for part B, use the quadratic formula to show that when k is greater than 5, the equation f of x equals to 0 has no solution. We need to use a quadratic formula. So f of x equals to 0 is this equation. Let me write this down. F of x is equals to 0 when k is greater than 5. This is your f of x, right? So we have 4 cos 4x plus cos square x and minus k equals to 0. Okay, now we need to apply the quadratic formula, right? So the quadratic formula here would be cos square x is minus b plus minus square root b square minus 4ac divides 2a. Now this is a quadratic equation in cos square x, right? So what is a, b, and c? A is a coefficient of this, b is a coefficient of cos square, and c is a constant term which is negative k. Now plug everything into the formula. We have cos square x would be equals to negative b plus minus square root b square minus 4 times the a and the c divides 2 times of a. Okay. Further simplification, cos square x would be equals to minus 1 plus minus square root 1 square is 1 plus minus times minus is plus 4 times 4 is 16k divides 2 times 4 is 8. Okay. Now here we have two cases, right? So the first one is cos square x is minus 1 plus root 1 plus 16k divides 8. Or the other one is cos square x is minus 1 minus root 1 plus 16k divides 8. Okay. Okay, from here, let me solve the second one first. Cos square of x, take a negative sign common. We are left with 1 plus root 1 plus 16k divides 8. Right. Okay. Now, what is taking a square root on both sides to get the value for cos, right? The square root and the same thing we can do negative of 1 plus root 1 plus 16k divides 8 and the square root with a plus minus sign. Okay, so from here this square and the square root is cancelled out. We are only left with cos x, and here plus minus root negative of something, and we know that square root of negative does not exist, right? So you can say square root of negative, you guys can see square root of negative 1, you can say does not exist. So from here, no solution, because square root of negative does not exist. Okay, so it is proved that by using the quadratic formula, when k is greater than 5, f of x has no solution. F of x equals to 0. By the first case, it has no solution. Let me use the second case. Okay, so as we know that the value of cos, the range of cos function, the range of cos function is, we can say minus 1 is less than equals to cos x is less than equals to 1. Okay, this is a range for the cos function, that cos must lies between negative 1 and positive 1. If the value of cos is more than 1, then or less than negative 1, we have no solution. And also for cos square, what is the range of cos square? This is between 0 and 1. For cos square, the range is between 0 and 1, right? Okay. So if the cos square is greater than 1, then we have no solution, right? We can say if cos square of x is greater than 1, we have no solution. So when cos square values between 0 and 1, we have solution. But when it is greater than 1, we have no solution. So let's see. This is cos square, and put the value over here and put greater than 1. So cos square is minus 1 plus root 1 plus 16k divided by 8 is greater than 1. Minus 1 plus root 1 plus 16k, this is greater than 8 times 1 is 8, right? Root 1 plus 16k, this is greater than 8, and shift the 1 on the other side, plus 1, right? Root 1 plus 16k is greater than 9, right? In order to get rid of this square root, take the square on both sides. Okay, 1 plus 16k is greater than 9 times 9 is 81. 16k is greater than 81, take away 1. 16k is greater than 80, right? And what is k? K is greater than 80 over 16. 80 divided by 16, it's 5. Okay, so from here k is greater than 5. So it is proved that when k is greater than 5, we have no solution, right? So we have proved in both cases that the equation f of x equals to 0, we put f of x equals to 0, write down the equation, then use the quadratic formula. We have two cases, right? With the help of this case, we know that the square root of negative number does not exist, so we have no solution. By this, we know that the range of cos square is between 0 and 1. If the cos square value is between 0 and 1, its solution exists. But if it is greater than 1, solution does not exist, right? So if I suppose that cos square is greater than 1, so when I just plug this value of cos square and simplify, we come to know that k is greater than 5. So it is proved that by using the quadratic formula, when k is greater than 5, f of x has no solution, right? So we can say in both cases, when k is greater than 5, f of x equals to 0 has no solution. Okay, that's the last question of our paper. If you have any queries, please let me know in the comment section and please subscribe to my channel. Thank you for watching. See you next time. Take care.